If not, you can write me in the chat. So I'll be here. Okay, so I think it's fine. So let's get started. Thanks for joining everyone for the session on chaos engineering. I welcome everyone for this session. So if you have any questions at any moment, you can write in the chat. So whoever connected from whichever the channel, so it can be Twitch, it can be Facebook or YouTube, you can write your questions whenever you need. So let's get started. Okay, so today session is chaos engineering. So the main topic of this session is improve resiliency and performance of the controlled chaos engineering. So what is actually chaos engineering? This is what we are going to talk about today. So this is chaos engineering. So everybody is here to know about more information about chaos engineering, and the main topic of the today is improve resiliency and performance with the controlled chaos engineering. So we have a special guest, Veliswa Boya, Senior Developer Advocate at AWS Amazon Web Services EMEA. So this session is a beginner and intermediate session. So you don't have to worry about if you are a beginner. So don't worry about that. So you just need to, you don't need any prior knowledge about AWS. So, so who is actually a? So let's talk about Veliswa. So Veliswa Boya is a senior developer advocate, and she's having 20 years of industry experience, and she is a firmly community hero, and she is expertise in cloud migrations, working with the financial organization and application teams to help the cloud architectures and cloud migrations into the AWS. She's a software developer and African woman. So the favorites of Veliswa Boya is working with AWS, architecting on AWS, and building a resilient architectures, AI and ML. So let me introduce Veliswa today. So Veliswa, thanks for joining today. So I welcome to you. I welcome to the board. So I hope you're doing fine.
Hi, I'm fine. Thank you so much, Ganesh, for that introduction. Hi, everyone. Thank you for joining. It looks like my camera is letting me down today, so unfortunately, I won't be able to switch it on. I hope that's okay. I'm going to share my screen just now. I'm going to share my slides. Do let me know if you're seeing the PowerPoint, the slideshow, or if you're not seeing the correct thing that you should be seeing. And then we'll start with the talk. I'll get into everything once I've done all the sharing. Are we seeing what we should be seeing? Because it should be there. Should be the PowerPoint slide, and for some reason that is not coming up here. Ganesh. Yeah, I think now that's the right one, right? Ganesh, we're seeing the slideshow.
Yes. Yes.
Okay, great. Okay, great. Let me start. Okay, so I'm speaking off camera today, but I'm sure you've seen photos of me, but I've got a photo of myself here somewhere, so you'll get an idea of what I look like. Again, thank you for inviting me here, and thanks to everyone who's joined. So, like Ganesh already said, today we're going to talk about chaos engineering on AWS. How can we improve resiliency and performance with controlled chaos engineering on your applications? Like already announced, you don't have to have prior knowledge of chaos engineering to actually follow through today. We'll go through everything from the beginning. Again, I've already said we're going to look at how to improve resiliency and performance of your applications with controlled chaos engineering. And I think controlled is actually the key word in the whole definition. I'm Veliswa Boya. I'm a senior developer advocate at AWS. I am part of the EMEA team, but I look after sub-Saharan Africa. I'm based in Johannesburg, South Africa. Uh, yeah, so there's a photo of me because there's no camera. So a little bit about me, like already announced, I'm based in Johannesburg, South Africa. I was an AWS community hero, first woman in Africa to be named a hero. It still remains the biggest honor, I always say. What areas of AWS do I like to talk about? Chaos engineering that we're discussing today is one of those. It kind of forms part of architecting on AWS. So those kind of go together for me. And I think my main interest in these topics is part of my background. Somewhere in my background, I was a solutions architect. I think next to this role is another role that I enjoyed more than all my other roles. I really enjoyed looking at things end to end, and that's what being an architect actually provided me. I also enjoy AIML on AWS or AIML in general discussions. I enjoy those. What are we going to look at today? The agenda is we're going to look at what is chaos engineering, and then we will talk about the challenges with distributed systems. And these challenges are what has led to actually, I think, why chaos engineering is starting to have a lot of relevance. So what is chaos engineering, and why is it hard to perform engineering, or why was it hard to perform chaos engineering before one of the services on AWS that we're going to look at today? And then we'll introduce AWS Fault Injection Simulator. FIS, we call it. It's the service that we're also going to look at today. We'll look at the key features and use cases of chaos engineering, and then there'll be a demo. I did promise a couple of demos. We'll look at those. We'll have a walkthrough of those as well. So before I start, I've got a story to share. I'm sure you also have a story to share. Probably there will be no time for you to share all your stories today, but if you have a story where at some point in your life or even now, you worked with applications and one day there was a fault and you did not know where that came from. I'm sure a lot of us can relate to that. If you have a story, you can put a one or emoji or whatever in the chat just so we know. I have a ton of those. Part of my background or how I started out, I was a developer and I did a lot of production support. And I remember I used to sit next to a window at one of the companies I worked for, and I would look out like on Friday afternoons. I would look out, and there'd be all these people having lunch, sitting outside, having drinks, catching up with friends. I never knew what that felt like because if you look after applications in tech, chances are your Fridays you are fighting fires. Someone took something to production, and there's been drama, and you're all trying to figure out what actually went wrong and how to fix that. That is part of why chaos engineering is so attractive to me. I always think, oh my word, I wish this was around 10 years ago when I used to write code for a living, like full time, getting paid to write code. So it's part of why it is so close to me and why it's such a favorite topic of mine. So, what is chaos engineering? There is um, I'm going to share the link at the end of these slides. This all started out as a phenomenon at Amazon. There is someone called Jesse Robbins. He started out chaos engineering, and then his background was he was a firefighter, and he brought the practices of what they used to do as firefighters, how they used to train for game day, they used to call it, and how they would do game days to prepare for actual firefighting. And he brought that onto Amazon, and that was the practice he brought in for preparing for when systems actually go down. What do you do? And that's how chaos engineering kind of started out, and it went in big scale when that went to Netflix. I'm sure a lot of us know the stories about Chaos Monkey. So, what is chaos engineering? Chaos engineering is when you inject events into your applications. You then monitor what happens. And then, out of what you see after you've monitored, you then act accordingly. You are injecting events because you want to see where are blind spots that you don't know about on your applications. So, that is chaos engineering. What are challenges with distributed systems? I've got a QR code. If you are able to access this, you'll be able to access the link and you can read. There's a nice write up by one of the principal senior engineers at Amazon. He says they knew at Amazon that they now had distributed systems when they installed a second server for Amazon.com. So that's a distributed system. You have more than one server or more, a lot of servers and components to your application. So what are the challenges with distributed systems? Distributed systems are complex, and it is sometimes quite hard to figure out where a fault is when you actually do encounter a fault. This link that I've shared, when I share the slides on later on, you'll see all the links are at the back as a reference, so you'll be able to check this later as well. But you can use that QR code if you want to read along now as well. So that's the challenge with a distributed system. It is hard for you to figure out where things have gone wrong. So this is what it looks like. What I just talked about, distributed systems being complex. You've got your client over the network speaking to the server, and messages are being sent, client over the network to the server, and the way back. This is a very simplified representation of what a distributed system would look like. A typical one out there is a lot more complex than this. So this kind of gives you an idea when we say distributed systems are complex. Of course, we try and test, but when you test, you're testing for something that you know already. You know what you're looking out for, and you just want to check whether your application is doing what you are looking out for. We perform different kinds of testing. Traditional testing is just proving to not be enough the more complex systems actually are becoming. You can do your unit testing of your components where you test a component in isolation on its own to make sure that it is doing what it's meant to do, that is, it's functioning according to expectations. Or you can do a functional testing of integrations. And here you testing end to end in a way. You are testing your execution path to make sure that you're getting the expected results. But I think you will hear with both of these, with all of testing, we keep saying expected. So you know what you want to see as the outcome. And it's good on its own, but what happens when you have things that you're not expecting? Then what happens? And this is where chaos engineering then comes into play. Chaos engineering helps you expose those blind spots that you may not have tested for because you didn't know what to test for. It helps you uncover your hidden issues that you don't know about. And because of this, it helps you improve resilience and performance of of your application. There's there's many more other stuff that it actually helps you do. So what you do with chaos engineering, you stress your application and then you observe what it does. And based on what you've observed, you then improve on your application. When we look at the demos later, you'll actually see how we actually plot this all out, and each of these things that I'm talking about, you'll see how we actually do each of those. So these are the phases of chaos engineering. It's very iterative. You see the wheel that I have. Again, I've got another QR code. Where you see a QR code is where you can actually access and then get a link to more information. We at Amazon we talk about a flywheel. It's so this kind of looks like that. So I can't even say where you start here. You define your steady state. Yeah, that's typically where you would start. You're defining your steady state. So your steady state, you're saying this is where stability of my system. This is what it looks like. And then you define a hypothesis. A hypothesis is now where you start to say um, um, uh, what when your system is stressed, what that would then look like, and the hypothesis you would test at the end of your experiment to make sure whether that actually happened. You run your experiment and then you verify. Where you're verifying, you are checking the hypothesis that you defined, you're checking whether that actually happened, and then you can improve. When I first came across chaos engineering, I would hear improve. I used to think you're improving your experiment, but what you're actually improving is your application, because you are stressing it so that you can see where the issues are so that you can then improve. So the improving is improving your application out of what the experiment has actually shown you as the weak point or a weakness in your application. But when we go to do the demos, you'll get to see all of these. So why is chaos engineering difficult, or why was it difficult? When you don't have a managed service or a safe place to do your chaos engineering, it can be hard because you have to stitch together different tools and scripts that you've written yourself. You bring in your agents, your libraries that you need to get started. And how do you then ensure safety? And how do you reproduce your events? Or say you want to reproduce multiple failures at once. How do you make sure that you do that? Now, that means you have to go back to that stitching together and those scripts that you've put together to go back and improve those. And it can be risky. And you want to be what you want to make sure to do is that you're doing your chaos engineering safely. So this brings me to the service that is part of the talk today, AWS Fault Injection Simulator. This is a managed service on AWS that lets you introduce chaos or faults to your applications in a safe way. It's managed, so everything is taken care of by AWS. And when I talk about safe, when we do the demos, we're gonna see what safe actually looks like. Things like when you first introduce chaos, best to do it in test or dev before you do it in production. Now you are able to make sure of all of that because you have a service that is there for you, that is managed for you by AWS. Um, AWS Fault Injection Simulator was announced at reInvent of 2020. And um, right now, when we move on to the next slide, you will see the services on AWS that you can actually perform chaos or introduce these faults on for now. The list is growing based on the feedback that we get from the customer. So you let us know what other services you want to be able to introduce faults to, and then we will definitely look at making sure that those integrate as well with FIS, with AWS FIS. Like I already said, it's a fully managed chaos engineering service. It provides you with three things as highlights. It's easy for you to get started. You can do real world conditions, and it provides you with safeguards. When I said easy for you to get started, what that means is I talked about why is chaos engineering hard, and I said you have to string together all these scripts and all these other homemade tools. You don't need to do that, and you don't need to worry about installing agents. You use the AWS's management console to get started, or you use an AWS API or the AWS CLI. when I started to implement to experiment with FIS when it was first announced, I used to use the management console, but I now use the CLI. You'll see the demo has got both. I'll show you how to use the console and how I'm using the CLI. You can use pre-existing experiment templates and get started in minutes. What this means is you define a template. A template feeds into your experiment. So you define a template for your experiment. You define a template once, and it can be used in multiple experiments. What's great about that is that you can also then share your template with others in your team. So there's reusability of those templates as well that you get. Testing of real-world conditions. You can run experiments in sequence of events or in parallel, because what does real life look like? Real life probably means that multiple things will all break at the same time, not just one thing. I think my demo that I have today is what they call blue sky, where one thing is breaking, but you can have more than one thing breaking at a time. I'll show you when we do the on the management console, when we define the experiment template. I'll show you how you can define for parallel, or you can define for just one thing. So you can define, you can target all levels of your system at host, at infrastructure, and network layer. You'll see with your EC2, you can go at CPU level, network layer, and your infrastructure when you're defining where you are injecting your faults. And you inject real faults at the service control plane level, and that's another great thing. So that's the second part of why the service makes it easier for you. You can do real world conditions. You can test for those. And then the third one and the last one is safeguards. It provides you with safeguards. You can define stop condition alarms. The second demo is doing that. We'll see what that looks like. And those integrate with your Amazon CloudWatch, and you can build in rollbacks. Those are built in, and then you can fine grain your IAM controls. We'll look at those as well, what those look like when we go and look at the demo. Targets or services on AWS that are supported for fault injections. Before I go on, if there's anyone with questions, you can send those questions at any time. Ganesh, you're welcome to read those to me if there are any questions in the chat. So services that you can define as targets for your fault injection: Amazon EC2 instances, ECS, which is your container service for Docker, for your Docker containers. You can define fault injections for API throttling, for Amazon EKS, which is your Kubernetes service, or your Amazon RDS, which is our relational database service. More will come, like I said, depending on what the customers are actually asking for. Customer feedback drives a lot of what we do here at AWS. So more will come based on customer feedback, but that's what we have for now, and that's what you can inject your faults into. So this would be their process flow, or the architecture of this entire fault injection simulator that you would actually play out. On your left, on my left, you see your AWS Identity Access Manager console CLI. Let's first look there. So you would go, for you to make sure that your entire experiment works well from beginning to end. So you would go to your AWS IAM, Identity and Access Management, and there you would define the user that will be performing the experiment, and that user needs a couple of access, which you would attach policies to allow them that. You attach roles, you define your roles, and then you've got your policies that would say that this user is allowed to perform your FIS experiment. And then on your management console, I mentioned options of where you can perform your experiments. On your management console, you can create your experiment templates. and then start your experiment. Or you can use your command line interface. Again, you create your experiment template, and then but then to start your experiment, you have to come back to the management console to do that. So that is then the integration with the fault injection simulator. That is that console, and then you see there the experiment templates that I talked about. You can define them there, and then your first engine is where you start and stop your experiments. And then we have that other block at the bottom where you see all the resources that you can perform these experiments on, your computes, your databases, your storage, and your networking, and then your safeguards, where you see Amazon Event Bridge and Amazon CloudWatch. That is where you define those stop conditions, and that's where you would have your alarms, which go with your stop conditions. And those are the safeguards for your experiments. And then right at the end, we've got third-party monitoring. You can either do your monitoring inside AWS or you integrate with a third-party tool for your monitoring. That integration can go from the third-party tool to Amazon CloudWatch. So you can have that integration there because CloudWatch will send metrics to that third-party tool, and that's where you would do your monitoring. So this would be the end-to-end process of what you would need to make sure that you have an experiment working successfully using AWS Fault Injection Simulator. Oh, now we're gonna go and look at the demo. I think let me finish the slides before I switch over to the console, to the browsers, so that I don't need to come back here. We're gonna look at 4 demos. We're gonna create an experiment template using the console. That's gonna be demo 1, and then demo 2. We're gonna create a template using AWS CLI, and then using those templates, we will stop an instance. And then using the other template, we will stop an instance with alarms. That's where we've got those stop conditions. And so what I have here is a typical use case. So there are people who go, fine, then I've defined, I want to do chaos engineering, but where does it actually fit into everything in my current applications right now? I can see what you're talking about creating experiment templates and running experiments, but where does it actually fit into everything? This is a typical architecture of where you would actually insert an experiment. Let's say, like you can have it as part of a CI/CD pipeline. Let's say you've got your source code residing in GitHub or whatever other source code repository. Then you every time there is a change, you are triggering a deploy to AWS using code deploy. What code deploy is, it's a CI/CD tool on AWS that deploys your code onto EC2 instances. So you've changed your code on your source code repository. There's a trigger because code deploys is talking to GitHub. It then takes that code and it will deploy it on an EC2 instance. What you could then do is, what code deploy will let you do is that you define stages. So you can say, okay, it comes onto dev when it comes onto AWS. And there, before you move on to your next stages, you can then, you could insert an experiment. So when it lands on dev, you could run an experiment, and then you say to code deploy, only once that experiment is successful do I want to move on to the next stage, all the way up until production. So that's typically where you would actually want to have, or where you would practically or in an automated way start introducing chaos engineering to your applications. And those are the references. I will share these slides, so you will get all of these links that I've been talking about. I also have them here where you can actually come and read more. You'll see the number 6 I talk, you see breaking things purposefully. That is that Jesse Robbins story that I mentioned. You can read, it's quite a fascinating story. You can read more about that day. And that is That will be the end of the slides, but let's now go onto the browser and start doing all the demos that I mentioned. Okay. Okay, so we're here. So I said the first one, we're going to go on to Fault Injection Simulators Management Console, and we're going to create an experiment template. And this template we will use later on. Before I go there, can we all see what I've now shared, the entire browser, right?
Yes, Veliswa, you can proceed. We can see.
Sure. Okay. Okay, so let's go on to the management console for Fault Injection Simulator. So this is where you will land when you come onto AWS Fault Injection Simulator. And again, I did talk about what it is, and this is the definition again. So you come here and you create an experiment template. Okay. I will call it, okay, what do I call it? Okay, Malta 1 stop EC2 instance. That's what I'm calling it. And you need to have a role that you've defined already. And this role has to be, has to have permissions to run the experiments for you. I'm going to pick this one. I did define a role earlier on. What this role does, if you want to perform experiments on EC2 instances alone, you must give it permission to just do that, because we always talk about least privilege as well. But if you want to do experiments on EC2s and ECS and EKS, all of those, then that role has to have permission to perform experiments on all of that. So that's the role. And actions. Now we're going to start adding actions. And here you're saying, you're defining your experiment, what must actually happen. And my action is going to be to stop EC2 instance. And I'm not going to input a description. That's straightforward enough. Action type, these are all the actions. I talked earlier about all the targets that you have. This is all that you can do in an EC2 instance. Everything you can do in an EKS. That's the API throttling that I talked about before. That's where you can do that. And that's the RDS faults that you can inject. And using SSM to do your to run your experiments as well. That can let you do that. So that is all that you can actually do. So stop instance and action. I'm going to choose stop an EC2 instance. The start after option. This is optional. So this is when, if you are running your experiments or actions one after the other. So maybe this one that I'm defining here is not the first one that I want to run. I want it to wait for another one before I want this one to run. And this is where you would define that here by start after. But here we're not having anything run before that. So we're going to leave it as is. And then a target. Now you must, it just gives it, this is automatically assigned for you, just assigns it a name. And the start instances after duration. This is also optional. So you can say, stop the instance, but I want you to start it again after a minute. Or you can stop it and that's it, you've stopped it. I'm going to have it start after a minute. This is in minutes. So I'm defining a minute, and so I'm going to save this action because now that's done. And then it's automatically gone and started to populate targets for me. And now I'm going to edit that target portion because now I want to define more variables here. So we've defined the actions. Now we must define the target. Action, so it's for that action resource target, and I've got a couple of EC2 instances that I've got a couple of instances that are running, and we'll just pick any of them and we'll run the experiment against. I'm just going to pick one. Selection mode, you can say all that fit that definition, or you do a count. So you can say maybe I just want one or two or three that you need to perform this on. But because I'm defining a resource ID, it's safe enough. So I'm going to go with all. And it's part of that safety, again, that the safeguards that I was mentioning before. And I'm going to save it. And for this one, I'm not going to do stop conditions. With the next demo that we're going to do, you're going to see what stop conditions look like. I won't tag it, and then I'm going to create the experiment. So it's created my my template now. So I've got a template, and then you can come into your actions, and then you can start the experiment. So my experiment is busy running, starting. Let's come and see what it's looking like for the instances. I just didn't note which one it is, but we'll see one of them will stop as soon as this actually starts running. Let's look. You can see there's already one that stopped. What I said in the experiment is that you stop it, and after a minute, I want you to bring it up. So I'll keep checking between what's happening with the experiment, how that's progressing, and what is happening this side, because this should come up after a minute. The experiment is still running. It does run for a while. So maybe while we're waiting for it to run, let's move on to the next demo that we're going to actually look at. They do run for quite some time. So we'll come back to this. I'm going to switch to my JSON file that I have for, remember I said you can create your template either on the management console or using AWS CLI. So I'll switch while we wait for this to run. Okay, see, it's coming up already. So we're almost at the end of this one. It's completed successfully. It can fail depending on conditions, but this one is completed successfully. And that instance is running again. So it's busy with status checks now because it's coming back up. So that's done. So that's the first experiment that's done. It's actually finished successfully. Okay, now I'm going to switch. Remember I said your experiment template either on the console or using AWS CLI. Now for this next one that we're going to do, we're going to create that using AWS CLI. Now I'm going to switch screens again. Okay.
If you have any questions, you can post the questions in the chat meanwhile, so that I can answer you.
Okay. So your other option that you have for creating your experiment template is using AWS CLI or calling an AWS API. For that, we actually have examples that we have, and you can use those as a start for how do you actually create, how do you define your JSON file. Let me get the link, and we will step through that. Okay, here. Can I share things in the? Can I share in the chat for the audience, Ganesh?
Yeah, sure, Veliswa. No
Can
worries.
I?
Yeah,
Okay.
yeah,
Let me share this because
absolutely.
I think it's pretty cool. It's very helpful for getting started. I see there are some questions in the chats.
Yes. So we have a question from Shiva. So what if we have a custom requirement where would like to test the infra resources apart from the AWS default test scenarios? It's a good question.
Mm, um, does this mean? Okay, let me start. Are we testing against one of the services that I said you're able to have as your targets on AWS right now? If it's not against those services, right now you won't be able to use FIS to test against them. It's only against the services that we have right now as targets. And then once you're in those services, there's certain actions that you can perform against those. So if those are not there, you won't be able to perform them as yet. But also, like I mentioned before, we are continuously improving and building out new things based on what our customers are actually asking for. So that is feedback that we will definitely will appreciate, because that will help us plan out what comes out next. So I want to step through this JSON file that I mentioned. You saw before I was clicking to define actions and clicking to define targets and clicking to define stop conditions. What you actually can do here when you are using AWS CLI is that you don't need all of that clicking. Um, that but what you're actually seeing here is directly translates to what you saw me clicking at. This one, what it does is it will do a stop and a restart of one instance depending on a tag that that instance actually has. We'll check when we go back to EC2 console, there should be some instances that already have this tag env environment prod. So one of those should be the one that gets picked, and only one. I talked about the counts. You can do you can say how many you actually want to be targeted. Here I've only said only one. I'm going to target one, so I've only got count one. And then the action that I want is against the EC2. I want to do a stop instance, and it will start after 2 minutes. And then the stop conditions, I've got an alarm from before, and this alarm guards against. So it helps you with that stop condition that you actually want to check against. So if your alarm is not in an okay state, then your experiment won't actually go through. I've already got a role that I've defined, and the role is has the necessary permissions to do all that you need to do here. So I've got the JSON file already, and I'm now going to kick off this, which will then create the experiment template, and then I'll go into the console to start the experiment like I did with the other one. So that is what I'm going to do now. Let me just go and grab that very quickly. Templates and as soon as I've done this, I'm going to jump back onto the FIS console, because I'd like you to see the experiment, the new experiment template as it gets created. Okay, so this was the command that I actually executed just now. My template is the name of my this That is what I'm running there. So I'm going to go back onto the console. I'm going to share that again, and we won't need to come back off the console again, and then we'll finish off everything there. Okay. Okay, now we're back here, and we should have a new template that's just been created. What's the time? Yeah, this is the one. Just got created just now. And let's look at it and let's see what it actually is saying there. It's just been created now. Those are the actions. It's doing a stop instance. It will start the instance that it stops after 2 minutes, and targets it's count one, where the resource target, like just like you saw the environment prod, and tags. I didn't tag it. Okay, there is a tag, and so now that we've got the template here, we can actually start the experiment from here. But before we do that, let's go to my two instances and actually see if there is one that fits all those conditions. I should have one that has the tag, one of those. So that's when I talked about the tag, that's what I meant. The key value store, and that's the environment env and value being prod. So this instance or another one that has got the same tag should be stopped once I start this experiment. So let's go back. We can see now all our instances are all running. Everything is fine. And now let's start this new experiment. Start. Okay, it's initiating. Let's see what's happening to the EC2 instances. One is stopping. Let's just look quickly what if it actually. So yeah, it's got the value. Remember that the tag that I mentioned, it's got that, so it does meet it, and that's why it actually got picked up. And it is. So if I had count two, and there is another one with the same tag, so there would be two stopping. But I just said count one, and it picked up the first one that it finds that meets that, and it's going to stop that. After 2 minutes, it will kick it up. It will start it again. So it stopped it. Let's see how the experiment is actually progressing. Still running. So this will run for a good 2 minutes, because we're starting that that instance after 2 minutes again. So at minimum, this will run for 2 minutes. And that will be the last, that is the last demo that I'm doing. While we're waiting for this to run, if there are any questions, thanks, Wesley.
Uh, I think everything is clear.
Let's go and see. I'm still at that stage where my demos have to work 100% as a freak out. I know my colleagues, they're very comfortable now where the demos aren't working and they troubleshoot in front of people. I'm not there yet. So I sit and make sure that everything works before I come and do the demo. One day I'll be confident enough to just I'll come and wing it in front of people. I'm not there yet. So today I sat and I made sure all my roles are fine, all my permissions are okay, because I don't need any surprises.
Yeah, I think maybe it's a good idea to have the demos in a video so that we don't have any troubles while we are doing.
I thought of that. I've got that as backup. I thought, okay, no, I don't want to do that. I want to do everything in front of people.
All
So that's
right.
next. That's as I used to do the videos. I thought, okay, next level is to not do the videos, but do the demos, but make sure the demo works. And then maybe my next level after that will be, let's just wing it in front of everyone. I don't know if
That's
I'll
good.
get
Yeah,
there.
yeah. It's great.
So, okay, while we're still waiting for this, let's step through some of those links that I showed, because I think this for me, it's gonna be on those slides that I'm gonna share, is so helpful. So we have got a few examples here where we show if you want to create an experiment template, what your JSON would look like. We have a couple of examples here for you. There's an example if you want to stop using filters, and this is not the one that I used. Here you've got a lot more filters. You're being very specific. It goes back to what I said about um, all those safeguards that you have to make sure that this is it's safe, it's done safely. So you're being a lot more granular here with what you're defining as your filters. You're even defining your availability zone, the state that you want to pick up. And this is the one I used. This one is not that granular. It just picks up an instance and it just says one, and it's just defining one thing, and that's the tag. Very helpful to get you started. Let me get other, and there's more examples. If you want to do API throttling, it shows you. Let me go, and there's another link that I think is a very great one to, um, and especially because people starting out, I know I'm still there. Defining permissions can be quite a thing. So I talked before that your user that is performing the experiment has to have the right permissions, and there's a role that is attached to the user, and that role has to have the correct permissions. And then you've got all of those policies that you have that you're attaching to all of them. This link will help you figure out how to define all of those permissions. You can, when you're starting out, you can actually literally copy paste each of these policies as they are, and you just attach them to your user and your role. As you get more comfortable changing and playing around with things, then you can come back and be more granular with these. So three things that I'm going to highlight. Let's start right at the top. Step one, you need your IAM user, and I was not going to be able to run that command on my on AWS CLI if the user did not have those permissions. So you define your user on IAM, and you can copy paste this policy from here as is, and you attach that policy to that user. This policy, it's got all the services as targets, but you can change this depending on what services you actually want to target. And this role we'll look at later. We'll look at this roles policy later. So that's all. You can copy paste this as is, and then just change the role name, change your account to your account name, and you'd be able to get going. And then the next thing that you're going to need to define, so you've done your user, then the next thing is your role. And again, this is this role. And this is a policy that you would define to this role. And then over and above attaching this role to that policy, this policy to that role, you go into the role and you do a trust relationship, and then this is what you would actually paste in there. The service linked roles in AWS FIS, you don't need to worry about this. AWS will do this for you. It's based on one of the permissions for your user. So this is done automatically. So there's only three places: a policy for your user, a policy for your role, and a trust relationship for your role. And you should be good to go. Let's see how far we are with everything now. Okay, that's instance is back up. So I am guessing the experiment is finished. It completed successfully. So that's it. That's how you would do chaos engineering on AWS. It goes back to um, I mentioned before that flywheel where we were looking at, where you would define the experiment, you verify, you define your what was the word? Go back there. where where you first you identify the targets. I think you saw when we do the experiment templates, we define those, and you define your steady state, and you form the hypothesis, and this is where you say what you actually expect to see happen when your experiment runs. And then after your experiment is done, you say, you then evaluate, and then based on what you see, you can then take action. And that is the end. Thank you very much. If there are any questions, I'm happy to answer.
Yes, we have a couple of questions. So the first one we can look at. Let's go from here. Veliswa, could you please share us with references where we can get to see the default test scenarios that can be covered from AWS so that if we have any custom requirements?
Okay, let me just read this again, just to make sure I understand.
Yeah.
Okay, if I understand this well, Shiva, I think what you're saying is you want to see what's actually possible now, and out of that, you then want to see what you would then be able to ask for as an additional if it is not already covered. Um, there's one of my slides. You'll see when I share the slides, slide 18. It's where I define the supported targets, and so that is what is possible today against those targets. And then within each target, there is an action that is available today. Let me see if I can find a link with the, if I don't find it now, we'll definitely share it later on, maybe through you, Ganesh, and then you can share with everyone. But yes, there is a way of sharing all of that.
Okay, so again, we have another question from Shiva again. So we have three questions from Shiva. So what if we want to integrate this FIS with CI/CD system? Could you please suggest the best practices?
Um, right now, I'm aware of integration with Code Deploy. Code Deploy is AWS's CI/CD pipeline tool. Um, I'm aware of that integration. I can check on Jenkins and all the other ones and see what's available, because I don't think we even have integration with GitHub Actions right now. I'm aware of Code Deploy, but let me check and get definitely confirm on that one.
Okay,
Okay.
so let's go the last one. Yeah, again the CI/CD, right?
Yes.
Okay, all right. So I think we are done. So
I,
I
s- I,
think
s-
we have.
I see another.
Yeah,
I
yeah.
saw a
So
question there. Sorry, Ganesh, at the top.
yeah,
Is
yeah.
there a way to check the status of output log in FIS? There is a way. Let me go back. Maybe I just did not. Um, let me go back to that one of the experiments that finished. Let me just click into one of them, see if this status, the logs are enough. If not, there will be an integration with CloudWatch, and there you'd be able to access more logs. Yeah, there would be on via CloudWatch. Anything that's not detailed enough here, you'd be able to see on CloudWatch because there is integration with CloudWatch.
All right, all right. So guys, if you have again any questions, do please post your questions in the chat.
Can I just ask for one thing before everyone disappears? Um, we're always looking to get feedback and make sure that we improve on these presentations. And
Sure, sure.
I've got a survey that I would just like to pass around to everyone if people have time, so that I know areas where I can improve, and also I can know um, what you would also like to hear from us in the future. Let me just grab the link to that survey quickly, and then I'm going to share it here with everyone. If you all don't mind, It would be very helpful.
Yes.
Ganesh, I can only see access to a private chat here. How do I post on the chat that's got everyone?
If you can't see, you just post the link here. I can directly share the link in the chat directly.
Okay. Okay, there it is.
Okay, so let me
Thank you.
sharing this, please. Guys, I have posted a link in the chat, so please do give your feedback. So it would be really helpful for Veliswa.
Okay. That's it from me. Thanks, everyone. I'm so sorry I couldn't put my camera on, but hopefully there'll be other events where we can see each other.
All right, all right. That's not an issue. Yeah, I think so. It's a good understanding about the maybe I pronounced in a different way because usually we are in Italy, so it's CHO is Chaos. Okay, that's fine.
uh,
Thanks anyway. So it's really a good session on chaos engineering. So maybe I have understand something better because previously I haven't seen this service. This is the first time on FIS, so it is a good service that we can try to implement in customer services to get more best practices in the cloud. Thank you very much, Veliswa. It's really pleasure with you talking with us today, and we are on social media. So guys, you do follow us in AWS UG Malta, Twitter, Facebook, and Slack. You can join the Slack channel. So if you have any questions at any time, you can post your questions either on the YouTube channel or our discussion meetup discussion group. So I'll try to getting back to you if you have any technical questions at any time. So we are here to educate the community free of cost. So we try to make you as expert in the cloud technology. So I'm getting more experts of AWS advocates or uh, chief evangelist to the user group as a guest speakers. And thank you very much.
thanks.
And thank you.
Thanks,
Thanks,
everyone.
ladies. Have a good day.
Bye.
Bye. Bye. Bye.